Hi everyone, this is Saad Aslam. I hope you are all doing well. I hope that you are following along with the competitive programming series. If today we are going to discuss another important question, that is how to implement queue using stacks. First discuss the problem statement, then we will discuss the approach of it, and after that we'll implement our approach in both Java and C++. Before moving on, if you haven't subscribed to my channel, make sure to hit the bell icon and all of the YouTube stuff. So let's go to my computer screen to discuss the problem statement. Okay, we have to implement queue using stacks. Implement a first in first out queue using only two stacks. Okay, so the problem statement is like we have to implement a queue, as queue is a FIFO data structure, like it is a first in and first out. We'll discuss more in the whiteboard section, and we have a limit of using only two stacks. Okay, so the stack is a LIFO. If it follows the LIFO approach, like last in and first out approach, and we have to make use of the two stacks to implement a queue. Okay, so we have to implement a queue that supports the normal queue functions like push, pop, peek. So push is like inserting element in the queue, pop is like returning element from the queue, and removing the element from the queue too, and peek is to return the element which is at the front of the queue. Okay, it doesn't remove the element, it only returns the element at the front of the queue, and the empty function that returns true if the queue is empty or not. Okay, so note, you must use only standard operations of stack. Like we have to use standard operations of stack like push, pop, and peek. We can make use of those functions to implement queue. Okay, and all other details. So here is an example. There is a sequence of push, peek, pop operations, and these we have to implement using stacks. Okay, so I hope you understand the problem statement. Now let's discuss the approach of it in our whiteboard section. So let's go to our whiteboard section. So here we are in the whiteboard section. So let's first discuss the approach of it here. So here you can see, let's first discuss the difference between queue and stack. So at the left we have queue, and at the right we have stack. As queue is follows the FIFO approach, like the element that is added first will be removed first. But stack is LIFO, like the element that is added at the last will be removed at the first. Okay, so here you can see, like, let me just check. So queue has a structure like, here you can see that queue element that is added at the back, it is also called rear, and the element is removed from the front. The basic operations are named as in queue and dequeue. Like in queue is like inserting element in the queue, and dequeue is like removing element from the queue. On the other hand, stack follows the LIFO approach, like and adding element in the stack is the push operation, and removing element from the stack is the pop operation. So here you can see the element that is added at the last is removed at the first. So here is the difference between the two, like FIFO and LIFO. There is a difference between two. Okay. Okay, so first let's discuss how elements are added in the queue. Let's first the basic approach, like how elements are added in the queue. So first, like the input is here, the input first here, it is the queue, and the first operation is push. So first element 1 is pushed in the queue, so we have added 1 in the queue. The next is 2. Here you can see 2, and we have to add it in the queue. So when 2 is added, 1 will remove to the front, like to the right, like, and 2 is now added at the rear. Okay, and the third operation is peek. Okay, so the third operation is peek. What peek will do? Peek will return the element that is at the front. Okay, the only return, like it doesn't remove it from the queue, only return the element. So the peek operation will return 1. So as you can see, after first operation it is null, and after second operation push, it doesn't returns, it only adds it in the queue. After second operation, like adding 2, it only adds it in the queue, so it is 1. And when the third operation, peak, so what will do, peak will return the element that is at the peak. Okay, so the element at the front here is 1, so it will return 1. Okay, so the next operation is pop. So pop also returns the element that is at the front, but it also removes the element. So here's the difference between peak and pop. Peak doesn't remove the element, but pop returns the element and also remove it too. So when, it will return 1, but here is the difference. There will be a difference in the queue because it will remove 1 from the queue. So now R2 is at the front. Okay, also I just appointed to the queue. So R also it is currently at front is also R. Let me just erase all of this. So R2 is also at front. Okay, so it is also front, just writing up. So it is also at rear and at the front. And now empty will check if the queue is empty or not. As there is an element in 2, so it will return false. So this is the basic operation of a queue. Like all the elements that are added first will be removed first in the sequence. Okay, now let's take some examples. Okay, so what we will do is like, okay, so now let's try to make use a more complex problem. So these are the operations listed here and we are going to add it in the queue. Okay, so the first element is push 1, so it is added in here. Okay, let me just erase and okay, so element 1 is added in the queue. The next operation is push 2. Okay, so what we'll do, like 1 will move towards right here and 2 will be added here. So now currently our 2 is at rear and 1 is at front. Okay, our next operation is pop. Okay, so it is our next operation. So what pop will return, it will remove the element that is at the front and also return it. So in our output here, something like it will be 1, it will return 1 and also remove it from the queue. Okay, so now currently R2 is both at rear and at front. Okay, so rear and front are pointing to 2. Our next operation is push 3. Okay, so push 3, what will do, like 2 will move towards the right and 3 will be added here. Okay, so now our front is pointing to 2. Okay, so currently our front is pointing to 2. Now our next operation is push 4. So what will push 4 do? All the elements will be moved towards right, like towards the front. Okay, it is okay. So it 2, 3 and 4, and now currently front is 2. Okay, so yeah, we have discussed this too. Now our second operation is pop. So what will pop do? Pop will return the element that is at the front and also remove it. So at the front is 2, so here in our output is 2 and it will return, also remove it from the queue. Okay, so now our front is pointing to 3. Okay, so what we'll do is like return the element that is at the front, so it will return 3. So here you have seen like it follows the order, like first element 1 is added, then 2 is added and 3 is added, and when popping out it from the queue it also follows the same sequence. This is the first in first out. Now try to implement this using only one stack. Like suppose if we follow this in a stack, usual stack operation. So what we'll do, like first operation is push 1. Okay, so here is push 1, it will push 1. Now second is push 2, it will push 2. Now pop what will do, it will pop from the top. Okay, so what is at the top, like element at the top is 2, so it will return 2. Okay, and also remove this 2, and now top is currently at 1. Okay, so now top is this. Now the next operation is push 3, so it will push 3 here. Next is push 4, it will push 4 here, and now currently the top is push 4. Okay, the top is push 4. Now the next operation is pop. Pop will remove, what will do it, like it will remove the element from the top, and we have two sequence of pop, so it will pop like 4, the element that is at, okay, it will return 4, and after it will return 3. Okay, so here you can see there is a difference between the operations using queue. The queue, it follows the sequence, like it follows the 1 2 3, but using stack, the sequence is different. Okay, so we have to make use of stacks to implement the same behavior like queue. So now let's discuss the approach we are going to use in this question. Okay, so for this we will use two stacks as discussed in the question. First stack will be a push stack, and the other stack will be a pop stack. As it is obvious from the name, whenever we are going, whenever there is any push operation, we are going to push it in the stack 1 push stack, and if there is any pop operation, we are going to pop it from the stack. But we also have to check conditions, like if the pop, like initially, like suppose we have added all the elements in the push. So first let's try to add it in the stack. So first element 1 is pushed. Okay, let me just, okay, so why it is, okay, so first element 1 is pushed. Now the next is 2 is pushed. Okay, so now we are going to pop. Here you can see currently there is no element in pop. So what we will do, we have to check a condition. If the pop stack is empty, then we are going to pop elements from the push stack and add it in the pop stack. So what we will do, like pop element from stack 1, so and push it in stack 2. So we will remove 2 from here. We will remove 2 from here, and we will add this in this second. So 2 will be added in the pop stack. Now our third operation, and also we have to move all the elements. Okay, all the elements that are present in the push stack. So this. So currently we are at this operation, and both the elements are moved to pop stack. Here you can see, you have noticed one thing, that it is now following the sequence of like the elements that are added in the sequence. Like for top is at 1 and the second element is at 2. When you are going to pop it from the stack, it will follow the order. So now we have moved the elements from the push to the pop. Now after moving, we are simply going to return the element at the top. So the element at the top is, what is, 1. So it will return 1. After this operation, it will return 1. Okay, and also we are going to remove it from the stack 2. Okay, and currently our top is this. So we have performed a pop operation in the sequence. And now our next operation is push 3. As usual, it will push 3 in this stack, and the next is push 4. So it will push 4 here. Now our next operation is pop. So here you can see our pop stack is not empty, so we do not have to currently we do not have to move the elements from the push to the stack. We have an element in pop stack, we can use that. So for this operation, what we will do is, like, we will return the element that is at the top. Okay, so it will remove the element 2 and it will return this. So our next operation is pop again. Now you can see that there is no element in the pop stack, so we will follow the approach that we have used earlier, that is moving the elements from the push to the pop stack. So we will move 4 from here and push it in this, and also we will move 3. What is this? We'll move 3. Okay, so now top is pointing at 3. Okay, and now we are going to return the element that is at the top. So what is at the top? It is 3, and also we are going to return 3, and our operations are completed. If there is another pop, we can simply return 4. So here you can see, if you have noticed one thing, like here you can see this is following the same sequence that we have implemented using queue earlier, 1 2 3 and 1 2 3. So this is the approach of it. We are going to use it. We are going to use 2 stacks, push stack and pop stack. If there's any push operation, we are going to add it in the push stack. If there's any pop operation, we are going to check if the pop stack is empty, then we are going to move the elements from the push to the pop. If there is not empty, like pop stack is not empty, we are simply going to return the element at the top. So that's the approach of it. I hope you understand that. Now let's try to implement this in our coding section. So let's go to our coding section. Okay, so here we are in our coding section. As usually, we are going to first implement this in Java, and after that we are going to quickly implement the same approach in C++. So let's start our coding. Okay, so as we discussed, we are going to use 2 stacks for it. Okay, stack 1, and the data type will be integer, and it will be push stack. Okay, and the second stack also for pop. In the constructor, we are simply making an object of it. So push stack is equals to new stack just don't like that, and pop stack so this is for constructor, and for push we are simply, as you discussed, we are simply going to push it in the push stack. Okay, so push stack is push and push the element in the stack. Okay, this is for push. It is simple. It is the in queue operation. Now we have to, for pop, we have to implement the logic for it. Okay, so first we are going to check if pop stack is empty. Okay, so if pop stack is empty, then we have to, what we have to do, like move elements from push stack to pop stack. Pop stack. Okay, it is top, not pop. Okay, okay, so for this, like for peek and pop, the same implementation will be repeated. So for this, we are going to implement another separate method so that we can avoid code duplication, because it is not just about writing code, it is about writing clean code. Okay, so for this, we are going to make another method that we are going to call for moving the elements from the push to the pop stack. Okay, so let's name this conversion. You can say conversion. Okay, so what we will do is like we get the size of the push stack, and on the size of the stack we are going to return we are going to run a loop that will pop the element from the push stack and add it in the pop stack. So int size is equals to, you can say it will be push stack dot size, and for int I is equals to 0, I is less than size, and plus plus and what we are going to do is like we are popping the element from push and adding it in the pop stack. So we can name it as that the element that is at the top, int top is equals to push stack dot pop and pop stack dot push. Okay, so this is the logic that we are implementing in the conversion method. So now let's call this method in our pop stack. So let's conversion, and if it is not empty or if it is as passed to the, you can save condition, we are simply going to return the element at the top from the pop stack. So return pop stk dot, what we will return is like it will return the element that is at the, okay, for peak we are simply using the same, just we have to return, let me just for peak is like it is not removing the element, just returning the element at the top. So we will use the peak method here. Okay, and for empty we have to return if both push and pop stacks are empty. So we can return simply like return we can return like push stk dot is empty and pop stack is empty. Okay, so we have implemented these methods. Let's quickly go through any syntax errors. I think that's it. Now let's try to run this code. So here you can see the code has been run successfully. For the test cases we have also discussed in our whiteboard section. Now let's try to submit this. So here you can see the code has been submitted successfully. So that is the implementation of the approach that we have discussed. I hope you understand the approach of implementation of it. Now let's quickly implement this code in C++. So here we are in our C++ section. So now let's quickly implement this code in C++. Okay, so here you can see the code has been submitted successfully in C++2. We have to make a little bit tweaks in it. Like suppose there's a difference in pop method in Java and C++. So what pop stack.pop will do is like in Java, it will remove the element 2 and also return the element. But in C++, it only removes the element, not return it. So for that we have to make a little modification in it, like we have to first get the element from the top method and then we have to pop the value. So in Java only pop method can do both of the operations, but in C++ we have to first get the element from the top method and then we have to pop the element. So this is a little modification in C++. So I hope you have understood the approach of it and the implementation of it. If you have any further questions, you can let me know in comments. You can reach me out on LinkedIn. I would be happy to help you. So till then, see you in the next video. Bye bye.